Support comes from the Missouri Forest Products Association, providing more than 41,000 jobs in the production of wood pallets, railroad ties, white oak barrels, hardwood floors, and more. Details at choosewood.com.
Welcome to St. Louis on the Air. I'm Don Marsh. Today we discuss the human heart. In a heartbeat, it can continue sustaining human life or take that life. For centuries, it's been a mystery, a medical challenge, and a universal symbol. Its history is the subject of a new book titled Heart, the History. Its author is cardiologist Dr. Sandeep Jauhar. He is the director of the Heart Failure Program at the Long Island Jewish Medical Center and the author of bestsellers Doctored and Intern. I spoke with him yesterday and welcomed him home. He attended medical school at Washington University.
That's right. I went to medical school here from 1995 to 1998, and I miss St. Louis a lot.
Well, we're glad to hear that. You have to come back more often.
I will.
Yeah. What makes the heart such an extraordinary organ?
Well, I mean, it's probably the most amazing machine that nature has devised. When you think about a machine that pumps 3 billion times in a typical human lifetime, pumps blood through 100,000 miles of blood vessels, never stops working. A typical adult heart could empty a backyard swimming pool in a week. So you're talking about this engine that just keeps on running, and it's absolutely essential for our lives. And really what's fascinating about it is that the heart has some unique properties that are unlike other organs. For example, the heart doesn't just pump blood to the brain, the kidneys, the liver. It pumps blood to itself. The heart can't function unless the heart is beating. So in a sense, the heart is self-sustaining. When you think about, we can't see our own eyes. We have a hard time using our minds to change our way of thinking. But the heart has this sort of self-referential property, which is amazing. And let me just say the last piece that I find fascinating about the heart is that it has some unique obstacles to treatment or surgery. Most people don't realize that as recently as the late 19th century, every organ in the body had been operated on except the human heart. The brain had been operated on, the liver, the kidney, not the heart. And the reasons are pretty obvious. The heart is always moving, so you can't really cut it open. And the heart's filled with blood. So if you do manage to cut it open, you would bleed to death. So the only way to operate on a heart is to stop it, and that would result in brain and organ damage. So this was a unique obstacle that the book talks about how scientists sort of overcame over the centuries.
And it wasn't that long ago that these major obstacles were overcome.
That's right. That's right. So, if you talk about operating on the heart, now we know that you need a heart-lung machine. But before a heart-lung machine was invented in the 1950s, doctors and scientists had to find other ways to operate. And, like I said, you can't cut the heart open or you would bleed to death. So one pretty fantastic, almost science fiction-y method for operating on the heart was devised by a guy named Walt Lillehei, who's generally considered the most innovative surgeon of the 20th century. And his idea was based on a pregnant mother carrying a baby. Now, a baby in the womb, a fetus, can't breathe because it's floating in fluid. Mm-hmm. So it receives oxygen from its mother. So what Lillehei thought was, well, if I'm going to operate on a baby, for example, with a congenital heart defect, why don't I hook the baby up to his parent and have the parent's circulation essentially serve as the baby's heart and lungs while the baby's heart is stopped and cut open. And that was a human heart-lung machine. And you can imagine the uproar across the medical community. The people said this is the first operation in human history that could kill 2 people. So these were some of the crazy things that doctors and scientists did to sort of overcome some of these unique obstacles posed by the heart. And the book describes these innovations in a lot of detail.
I read your book and I enjoyed it because I have heart issues myself. And actually, your book made me afraid of my heart because so many things can go wrong.
Yes. I discovered a few years back when I had a sort of routine CAT scan. I was a first responder at 9/11, and I was having some bronchitis and breathing issues. So a pulmonologist sent me for a CAT scan, and it found I had coronary plaque. And then I went for a CAT scan that showed that I had blockages in my coronary arteries that were, not insignificant. And so I myself also sort of have this fear, and I've always had actually this fear of the human heart because, it's the only organ that can kill you suddenly. You could be healthy, walking around, talking with your friends, loving life, and then just suddenly be felled. And that's what happened to both my grandparents, and that was one of the reasons why I grew up with this fear of the heart as the executioner of mostly men, at least in my experience, in the prime of their lives.
You still feel that way?
I think that we've come a long way. We have amazing technologies today. We have amazing drugs. But we have, I think, come toward near the end of what I think the conventional technological paradigm can achieve in prolonging our lives. And I think that the view of the human heart is that it's a machine, but we know that the ancient philosophers thought of the human heart as the seat of the soul or the repository of the emotions. And I think that we have to pay a lot more attention to our emotional lives to get the kind of benefit to our heart health that we're used to getting from technology.
I want to go into that in a little more detail, but just referring back to something you said a moment ago, I have a quote here from the book in which you say cardiology may have reached the limits of what it can do to prolong life.
Yeah.
That's fairly disquieting.
It is, but if you view it in its historical context, it's actually pretty uplifting. Heart disease was the number one killer, has been the number one killer in the United States for the last century. The only year that it was eclipsed was 1918, the year of the great epidemic of influenza. Across the world, 18 million people die every year of heart disease. So the mortality from heart disease peaked the year I was born, 1968. And ever since then, there's been a steady decline. So if you look at it historically, we have achieved a lot. In fact, I would say that heart science is one of the great success stories of the 20th century. But more recently, a lot of studies seem to suggest that the decline in cardiovascular mortality is slowing down. And there was a point a few years back where people thought that cancer would eclipse heart disease as the number one killer. That hasn't happened, mainly because heart disease is the decline in heart disease deaths is slowing down so much.
What remains to be done? If we've reached the end, really, of progress, if you can wave that magic wand, what would you be asking it to do?
Yeah, well, let me qualify by saying that I don't think we've reached the end of progress, but I do think that there comes a point where you can only expect technology to offer so much. So, for example, when people had heart attacks in the 1950s and 60s, they had a 30% mortality in the hospital. 1 out of 3 patients died. Now it's 3%. So, we have sort of become the victims of our own success. Cardiovascular science has done so much to prolong life that we can't expect the same kind of progress. So what I would say is let's look at areas that have been largely ignored, like our emotional lives. The American Heart Association still doesn't consider stress, emotional stress, as a modifiable risk factor for heart disease, unlike high cholesterol, for example, or hypertension. And mainly, I think, because it's easier to lower cholesterol than it is to lower emotional and social disruption. So I think we have to pay a lot more attention. I think that is the sort of the next frontier in heart health.
Well, that's what people like you are asking us to do all the time, to modify our diets and exercise and relax. I mean, in your book, you get into yoga and Zen and that sort of thing as being very important in this area.
Yes.
Yeah. And, you know, in reading your book and looking at the illustrations, I couldn't help but think of the heart as kind of a Rube Goldberg device. I mean, obviously what it does is remarkable.
Yes.
But the way it's kind of put together, it's like a committee did it, if you understand what I'm saying.
Yes. It's fascinating. You know, it's like the most intricate machine. You know, I used to think of it as a house. In fact, I do describe it as a house. But it's a house that's been designed over many thousands, millions of years, where the plumbing and the wiring is not, you know, readily discernible. But that plumbing and wiring is so essential for the house to function the way it's supposed to. So yeah, in the book, I try to explain the basics about how the heart works in a way that's friendly to layman terms, so that people really understand how we've come to make the progress that we have, and they can use the knowledge to improve their own heart health and sort of improve their own sophistication with you know, the basics of medical science.
And it's a house that generates its own electricity.
Yeah. Yes.
Tell us about that. That's a remarkable part of the story. I mean, I had no idea.
Yeah. So the heart is fundamentally an electrical organ, and you know, what happens is that it generates a self-sustaining electrical impulse, you know, way up high in the top chamber that propagates downward. You know, it's like when you hold a rope tied to a wall and you jerk it up, there's a wave that propagates down that rope. And the same thing happens in the heart. And, of course, it's very intricate, and the wave slows down in certain spots. Sometimes the wave starts to circulate in these very counterproductive ways that can cause the heart to actually stop or defibrillate. That, incidentally, was discovered by a guy who, a phenomenal physiologist named George Mines, who actually fibrillated his own heart and died in the course of understanding how the heart's electrical properties function. And the book really talks a lot about some of the very outlandish things that people did for us to be able to come to our current understanding about how the heart works. A lot of self-experimentation. People died, scarred up their own veins. I mean, so we owe a real debt to some of these pioneers.
Yeah, they certainly were dedicated to the craft. There's no question about that, given what they did to themselves.
Yes.
We're talking to Dr. Sandeep Jauhar, who is the author of Heart, A History. We'll come back and continue this conversation in just a moment. This is St. Louis on the Air on St. Louis Public Radio, 90.7 KWMU.
Thank you for listening to this St. Louis on the Air podcast supported by University College at Washington University, with undergraduate and graduate programs part-time, evening, and online. University College at Washington University, offering world-class education within reach.
Back with Dr. Sandeep Jauhar, author of Heart, A History. Let's talk for a moment, as you did at the beginning of the book, about the metaphorical heart. Something about the heart since the beginning of time, I guess, has always captured the imagination. You indicated that early on, but it's always been a great mystery and a great source of many different things for people. Tell us about some of those things that you found and find most interesting.
I find it fascinating that the heart, you know, in the conception of the ancient philosophers was, considered the central point of the body. It was various philosophers considered it a sentry that gave warning signals about potential dangers. Others thought of it as the seat of the soul. Poets and philosophers throughout the centuries have talked about the heart as the locus of the emotions or the affections. And one thing I found fascinating and really motivated me to write this book is that, when I was in training, we just talked about the heart as this very complex biomechanical pump. It had certain wires that needed to be fixed sometimes and pipes that needed to be unclogged and sometimes the whole thing needed to be replaced. But it was fundamentally a machine. And we know today, I believe, that the heart is just so much more than that, that the metaphorical conception of the heart as being the container of the emotions isn't precisely true. I don't think the heart does contain the emotions, but our emotional lives are written on our hearts. We know today that emotional disruption causes a lot of damage. I wrote a piece in the New York Times about a week ago about this phenomenon called the broken heart syndrome, where people, usually after a romantic breakup or the death of a spouse, will actually suffer an acute decrease in their heart function, and it's called Takotsubo cardiomyopathy, and it's called that because the heart changes into a distinctive shape that actually resembles a Japanese octopus trapping pot called a Takotsubo, and this has been seen now for a couple of decades. It's relatively new, and it was first seen in people who suffered emotional and physical trauma but didn't die from the trauma. They died from cardiac causes, and autopsy studies showed that their hearts had actually acutely weakened. So there is this sense that heartbreak that the poets talk about actually has a biological manifestation.
How did the heart become the symbol of love? The heart as a symbol as we know it and we see it, we're all familiar with that.
Yeah. The
actual heart doesn't look very much like that at all.
Yeah, I know. So there's a lot of mystery behind that. The shape, the Valentine shape, is found in seeds and the cross sections of seeds and various plants, and it also resembles a seed called silphium, which was used for birth control, way back when, and that may be one of the reasons why the heart became associated with sex and romantic love. We don't really know, but we do know that by the 13th century or so, poets were using the heart shape to convey love. They were painting it red, which is the color of blood, which became a symbol of passion. And pretty soon you had the Catholic Church, using the Valentine heart as the Sacred Heart of Jesus, which was adorned with thorns and emitted a sort of ethereal light. So this sort of metaphorical conception of the heart as the symbol of love, whether it's sexual or romantic love or even monastic love, has been present in our culture for centuries.
So we know that the heart can be affected by emotion, as you've indicated a couple of times, and you've indicated how it is affected. How about stress? If stress is not the principal villain in all of this, it does have some effect on the heart, I'm sure.
Absolutely. So I distinguish in the book between acute stress and chronic stress. So acute stress is like the broken heart syndrome. You suffer a romantic breakup or the death of a husband, and you develop this acute congestive heart failure and sometimes death. Chronic stress is a more insidious thing, but there's a lot of evidence to show that people who are unhappy in their marriages, unhappy in their jobs, have this chronic sort of hormonal activation that can damage the heart. And there have been, and I talk about this in great detail in the book. For example, you look at Japanese immigrants. Natives in Japan don't have heart disease. They have very little coronary disease. But Japanese immigrants who move to the U.S. have a lot of heart disease. Now, people used to say, oh, that's just because they eat poorly like Americans do. But it turns out that if you correct for that, the Japanese immigrants, if you separate them into two groups, one that sort of retains their Japanese-ness in terms of culture, and those who become more westernized. The westernized Japanese immigrants develop a lot more heart disease than those who sort of maintain their cultural ties. So it's very clear that cultural and social factors affect heart disease. It would be impossible to explain that without invoking that as a thesis. So I talk a lot about that and how other forms of stress increase the risk of coronary disease.
It seems to me that what is happening is that the heart is damaged and potentially destroyed, if that's the right word to use, more over time than in sudden incidents.
Yes. It's slowly stress slowly corrodes the arteries, I talk in the book about a study that was done where people were separated into two groups. One had a healthy diet, exercise, and stress management, and another group that had sort of usual care. Now, the group that had the intensive diet, stress management, etc., they had regression of their heart disease, regression of the coronary disease. The group that didn't had progression. Now, there were people in the group that didn't who followed actually really healthy diets. The only thing that was missing is that they didn't have the stress management piece. And their heart disease still progressed. So it's very clear from such studies that stress management is as important, if not more important, for the development of heart disease than diet or exercise.
What has the most damage potential for the heart internally? Is it plaque? I mean, we talk about stress, and I get that, but all we're hearing about anymore is the plaque buildup and cholesterol, and that ultimately, if you don't deal with that, it's going to kill you.
Yeah. So what causes plaque buildup? One thing is that the way we understand how plaque forms is that there's a little bit of plaque, and then that plaque ruptures, and platelets and other blood cells come and sort of build the plaque even more. So what causes that rupture? Well, one of the things that causes it is stress, emotional stress. Emotional stress can cause ruptures that can actually cause a full-blown heart attack or cause sort of smaller disruptions and ruptures that cause the plaque to build up. So it's pretty clear that you have to keep your cholesterol under control, but if you do that, you're only sort of going halfway.
Mm-hmm. I'm looking over a list here taken from your book of the various advances that have taken place, and a couple of them I'd like you just to talk about, if you don't mind. You've already talked about early surgeries and cross circulation, which is when you have two humans hooked to each other, and they're really. How did that work out? By the way, was it successful most of the time, or part of the time?
It was, compared to the natural history of kids with congenital heart defects in the 40s and early 50s before cross circulation, it was considered it was a success. So kids lived longer. There were deaths, but historians have judged cross circulation to be successful because there was definitely a decrease in mortality in kids with heart defects using the technique. It wasn't a perfect technique, and there were cases I talk about in the book where a healthy parent died or developed brain damage because of problems with hooking up the circulatory systems of the two humans and developing air bubbles and so on. But that's cross circulation was successful.
No, you talk about that and the the notion of genetics playing a role, congenital heart failure in a young child, for instance, is the genetic component to all of this a very significant one or not so significant?
It is. We know. I mean, today we still know that 30,000 or so kids with congenital heart disease, die in the United States. So, and most of that is driven. That's not acquired. That's congenital. That's through heredity. So problems like holes in between the chambers of the heart, or having single heart chambers instead of dual heart chambers. All these things are driven by genetics.
Yeah. You hear a lot of people, let's say in their 40s, for instance, presumably very, very healthy, are just walking down the street or jogging and drop dead. And then you hear that, well, his father died of heart failure when he was 42.
Yes.
I mean, you hear that a lot.
Yes, yeah. There was the famous case of the long distance runner
Right.
who had written books. I forget his name,
So I do
but Healy maybe. Anyway, he'd written about how running helps prolong life, and he died suddenly in his 40s. May have been his early 50s while running. So it's there's no one size fits all approach. You really have to bring in all the different data streams. What's your cholesterol? What's your blood pressure? What are your family genes? And what is your emotional stress? And look at the whole picture to devise, a proper treatment plan.
Yeah. If you had no plaque in your heart, and if you ate all the things you were supposed to do and did the exercise you were supposed to do, how long would the human heart last? Would ultimately it just wear out?
Well, that's a really good question. I mean, I think the question really more fundamentally is there a time limit on human life? And has nature sort of created organisms to die to make room for other organisms to propagate life? There is evidence that there's so-called cell death or apoptosis that occurs in the body as it ages. But we do know that in a petri dish, if you culture chick heart cells, those cells can beat for something like 30 years, much longer than a typical chicken lives. So there's something about the heart that just makes it want to beat. And that experiment I'm describing, which I do talk about in the book, won a Nobel Prize. Alexis Carrel, did that experiment showing that the heart cells, they want to beat, and it's hard to turn them off.
Well, gerontologists are saying today, by the middle of this century, we could be living to be 120 years old. The heart is capable, then, you think, of keeping up with that, should that occur?
I think the heart probably could keep up with that, but I think there are, the heart's not the only actor in the body. There are other links that are potentially weak.
Yeah. Where are we right now with regard to the artificial heart? You spend a lot of time on that in the book.
Yeah.
And the difficulties in coming up with something that would work.
Yeah.
How what's the word I'm looking for? How effective are they now?
They're very effective, but they have a lot of complications. So you remember the first total artificial heart, permanent artificial heart, was implanted in a Barney Clark in 1982. He was a retired dentist from Seattle, had end-stage heart failure, went to Utah, got artificial. He actually went to a cow lab and saw how calves were being kept alive with these artificial hearts, and he said, I want nothing to do with it. But then he got sicker, and eventually he agreed. He lived for 112 days. I talk about this in a lot of detail in the book. And, a lot of people felt at the time and still feel that he didn't die for 112 days, but did he really live? He stayed for that entire time in the hospital. And I think that artificial hearts today, total artificial hearts, have a lot of problems, the same sorts of problems that they had back then. Blood doesn't want to course through plastic and metal. It much prefers a human artery.
It coagulates, doesn't it?
It coagulates. It clots, and clots can form strokes and so on. So the workhorse of heart support today is something called an LVAD, which is what Dick Cheney got before his transplant, and that's sort of but even LVADs have a lot of issues. Best to keep your own heart.
Yeah. Well, transplants seem to be working pretty well these days. Cheney's still with us.
Yes.
Yeah.
Yes. Yeah. Heart transplants are very effective. They're probably the most effective treatment for end-stage heart failure. People can live, on average, 14 or so years, sometimes longer, sometimes shorter. But they also have to take a very complicated drug regimen. So it's not something that we want to do lightly.
Yeah, and they can be hard to find, I'm told.
Yes.
One final question. I know you've had a long day already, but I was struck in the book by the fact that most of the experimentation, as I saw it in the book, with the heart, was performed on dogs.
Yes.
And I would have thought maybe pigs would have been a better choice because I've always under the impression their hearts are a lot more like ours.
Yeah, dog hearts, they have sort of a unique circulation. So you're right. Pig hearts do resemble human hearts more closely. In fact, when we talk about xenotransplantation, having animal organs be transplanted, the model for that is the pig heart. Yeah. But you're right. A lot of the research done in the 40s and 50s was on dogs. That may have been just because they were easier to cultivate. It's not clear, but the pumping of dog hearts is actually very similar to human hearts, and the pump studies were mostly done on dog hearts. The coronary blood flow types of studies and the electrical studies were done more on pig hearts.
Well, I have to say, Doctor, that your book is really a fascinating read.
Thank you.
And I enjoyed it very much and learned a whole heck of a lot by both reading the book and talking with you now. Is there a final thought you'd like to leave our audience with, some good advice to keep that thing pumping and ticking for as long as it can?
Well, it just reiterate what I said earlier, that we have to pay attention to our emotional lives, that we've come so far in cardiac science, but a relatively unexplored area in cardiac science is how this mind-heart connection, and I think that's something that we really need to pay more attention to. How you cope with stress, how you transcend distress, the quality of your relationships. These things are also a matter of life and death.
In other words, just chill.
Yeah, that's a succinct way of putting it.
Right. Doctor, thank you so much.
Thank you.
Dr. Sandeep Jauhar, author of Heart, A History. He's a medical student at Washington University more than a decade ago.
Support comes from the Missouri Forest Products Association, providing more than 41,000 jobs in the production of wood pallets, railroad ties, white oak barrels, hardwood floors, and more. Details at choosewood.com.